So hello there guys, how you all are doing? I hope you all will be doing fine.
Fine. No, not fine. This is not fine.
Welcome back to Rejoin Tech. We are again back with a new video, this time in Leetcode Marathon playlist.
People want my playlist.
This video is all about moving zeros to the end of an array. Moreover, if you haven't subscribed to the channel, kindly do it and don't forget to press the bell icon so that you get the notifications as soon as a video is posted and you don't miss any of them. The agenda of this video will be to solutionize the problem, then we'll do a dry run, then we will code out the brute force, and later we'll go to the efficient one. And moreover, this question is present on Leetcode platform, so we will be doing every coding part on Leetcode itself. So let's begin this video. So first of all, let's see what question is trying to ask us, what are inputs and what is the expected output. So input is 1, 31, 2, then there are 2 zeros, then 21, then a 0, then 23. Now the output is damn simple. We just need to club all the non-zero integers together. So it will be 1, 31, 2, then 21, then 23, then all the 3 zeros at once. So moreover, one more thing you need to keep in mind while solutionizing this problem is that the numbers should be in the sequence. So first 21 is coming, so 21 must be here. It shouldn't be like 2, 23, then 21. It should be in sequence. Now let's see how we can code this out. So here is our brute force code. What we are doing is just simple. We are traversing the array all one by one from the left side. Then we are trying to find the first element, that is 0. So we got the first element as 0 after 2. So what we are doing after that, we are initializing one more loop, one more inner loop that starts from I plus 1. So it starts from the next index from the 0. And what it does, it tries to find out the first non-zero integer. So you get the first non-zero integer as 21. Then you just swap I with j. So 21 will come here and 0 will go here. So this is the simple stuff. Moreover, we have written a swap function. We could have done it in place, but I wrote it so that it makes your life little easier. So we are just initializing a temp variable as ARR of I. Then we are replacing ARR of I with ARR of j, and then ARR of j with temp. So this is damn simple. So now let's do a quick dry run. So what will happen? Let's write our I and j. So now our loop starts. Our loop starts at 0. So I is here. Now it checks for if ARR of I equals to 0. So it is not 0. So loop will move on. Again it will check. It is again not 0. It will move on. Later again it will check. So this time it is 0. This time it is 0. It will come inside the loop. Now it is initializing j equals to I plus 1. Our I is this one. This is initializing j to be this stuff. Now it will go on this loop till ARR of length. So that means this inner loop can go till end of the array. So now what it is checking, if ARR of j not equals to 0, that is the first non-zero integer. So this particular is 0. So it will move on. This part won't be executed. It will move on. It will come here. Now ARR of j, that is 21, is not equals to 0. Then what we want to do, we want to swap I with j. So what will happen? This will become 21 now. And this in turn will become 0. And the loop will break. Even if you don't want to break it, you can escape it. But let's do a break. So the loop breaks. Now this comes out of the inner loop. Again outer loop runs. This time I will become this one. That is again 0. And it will try checking out it. So this is 0. It will come inside this. Again a j will be initialized with I plus 1. So it is this one. So it will again try to find out when ARR of j becomes a non-zero integer. So this won't run this inner statement at 0. Again 0 comes. It won't run because it wants to check for non-zero integer. Now this comes here and this is a non-zero integer. Now again it wants to swap I with j. So this time our I is this one and j is this one. So what we'll do, we'll simply swap it. It will become 0 and this in turn will become 23. So this is our expected output and this is how we are gonna do it. So now let's write our code on Leetcode. So first of all, let's make a swap function. Public static void. We are making it void because we are doing everything in place. We are taking the array, inside that array we are changing the numbers and we are giving back that. So it will be int of ARR, then int of I, and lastly we have int of j. And the same logic we'll write. First of all, int temp equals to ARR of I, then ARR of I equals to ARR of j, and later ARR of j equals to temp. So this is how we write the swap logic, and please try to code it yourself, this swap logic, and try to play with it, tweak things, because swap logic is going to come a lot in DSA. Now coming back to our main logic, let's have a for loop for int I equals to 0, I less than ARR dot length, and later I plus plus. This we are done. Now we will check for 0. If ARR of I equals to 0, then we want to make another loop that will be for int j equals to I plus 1, then j again less than ARR dot length, and lastly j plus plus. Then here in this loop we want to find out the first element that is non-zero, right? So we will write ARR of j not equals to 0. Then what we want to do, we want to swap our ARR I and j, and later we want to break out of this loop. So this is it. Let's run our code. Let's see whether there are any syntax errors. So there is one syntax. It's not a syntax error. We just need to rename it to ARR. Now let's run it. And hopefully it is accepted. Now let's submit our code. And as you know, this is a brute force. So time will be something around, yes, 40-45 ms. So this is kind of big O of n square time complexity, but we want to make it efficient. But you can see the brute force is the first approach that should come in your mind whenever you are going to attempt a solution. So this is how we code it out in brute force. Now let's learn the efficient one. So in our efficient approach, we are having a counter variable that counts for non-zero elements, number of occurrences of non-zero elements. So let's see what we are trying to do. So say for example, we are at here, our count will be 1. Then this time count will be 2. This time count will be 3. Now we got a 0, correct? We'll move on. We'll have this as the next integer. So what we'll do, we will just do a swap of count of I, that was 3. So index will be 3 this time, and it will be pointing to 0 with the non-zero integer. So that is what we are trying to do. And at last, our count will be at this position. So our count will be 1, 2, 3, 4, 5. And 5 is this index. So at starting of this index, we'll initialize all the zeros till the length of array. So let's see how we are doing that in code. So first of all, this is just a guard clause that if ARR.length equals to 1, that is only one element is in the array. You just return it, because if it is 0 or 10 or whatever it is gonna be 1. So we just want to return it. Now moving forward, we are initializing a counter that is 0. Then we are moving on with 0 till the last of array. Now what we are checking, if ARR of I not equals to 0. So if any element that is not equal to 0, then just do a swap of that element, ARR of count with ARR of I. Then increment the count. Later, at the end of this loop, we will just do till count is less than ARR of length, ARR of count equals to 0, and later count plus plus. So let's do a dry run and let's see what we are trying to do. So we only have one variable this time and one count as well. So let's write a count. And now let's see how it is trying to implement it. So at present, our count is 0. So it will be here. Let's write it as C. So at present, our C is 0 as well as I is 0. Now, if ARR of I not equals to 0. So what is our ARR of I? It is 1. It is not equals to 0. So it will do ARR of count equals to ARR of I. So that is ARR of 0 equals to 1. So it's kind of a redundancy. I mean, it was already at 0th position, but we want to do that. Now I moves on as well as count moves on. Count becomes 1. Again, it will swap 31 with itself. because we are doing that itself, ARR of count, that is ARR of 1 equals to ARR of I this time is 1. So again same, then again count increments, I increments, then we are again swapping it, then count increments as well as I increments. Now it will see whether ARR of I equals to 0 or not equals to 0. So it is equals to 0. So this particular if logic won't be operated this time. So I will move on, but count will stay at 0 itself. Why? Because this particular logic didn't perform. Count plus plus didn't perform. Now this time I again comes, and this time again I is not equals to 0. So we want to do ARR of count, that is this particular one equals to ARR of I. So it's kind of a swap. So what we did, we just written 21 here. And there also is 21. Why? Because it's not a swap. We are just doing a one-way swap. So ARR of count is only changing to ARR of I, nothing else. Then again we are doing a count plus plus. So now in the next iteration, I will come this side and it will try to execute this one. But as you see, ARR of I is equals to 0. This loop won't execute. Now again, I will go to this place and again it will try check out ARR of I not equals to 0. It is true this time. So again, it will do a swap. ARR of count equals to ARR of I. And our count was at the 21. So it will just make this 21 as 23. Nothing else changes because it is a one-way swap. We'll do count plus plus. So count will come this side now. And in the next iteration, again, I will go to 0. So now our loop ends because I is already at ARR.length. And this is 0. So this won't affect anything and this won't change. So now our count is at this position and we have got our output arrays half part, that is all the non-zero integers we already have. We just need to add all the zeros at end because the question says move zeros to the end. So we are at the first occurrence. So what we are gonna do, while count is less than ARR of length, so count is here, it needs to execute 3 times. We need 3 zeros. Then ARR of count equals to 0, count plus plus. So what it will do, first of all, count is here. It will make count as 0. It is already 0. Then again, it will go this side. Again, it will make it as 0. Then again, it will go this side and again, it will make it as 0. So we got our output array. So this is how our efficient code works. Moreover, this is only one time we are running the loop. So this makes it big O of n. So we have 2 loops, but they all are running at 2 different times. That is kind of a sequential and not nested. So this makes it big O of n, that is a linear time complexity. So this makes our code efficient and this is how we are doing it. Now there is one more variety of this. So rather than doing a one-way swap here, you could have directly written our swap logic, which we have done in the last part of the video, that is in brute force. So rather than doing this particular while loop, we could have done a swap logic. But this seems to be a cleaner solution. First of all, we are making a guard clause. Then we are swapping for all the non-zero integers. Then we are doing stuff for all the zero integers. So this is how is our efficient code. Now let's go to Leetcode and code this out. So first of all, we'll have our guard clause, that is if ARR.length equals to 1, then we want to return it. Okay, now let's have a for loop. Let's give ample amount of spaces. So it will be for int I equals to 0, I less than ARR.length, and later I plus plus. Moreover, we need a counter variable. So let's name it as count. Int count equals to 0. Now we need to check if ARR of I not equals to 0. Then what we are gonna do is we are gonna write ARR of count equals to ARR of I. We are doing a one-way swap and later we are doing count plus plus. Now lastly, after this for loop, we'll have a while loop in which we are gonna check while count is less than ARR.length, we will just do ARR of count equals to 0. And we'll increment our count for while loop to perform. So in this part, we are managing for 0. This part we are managing for non-zero integers, and this is our guard clause. So this is it. Let's run and see whether we are having any syntax errors. And that is not the case. Then let's submit it out and let's see what is our runtimes and all. So this is it, guys. It shows 2 ms runtime, but this is kind of a little bit of problem with Leetcode. So if you do a resubmission and all, it will come to 1 ms. And if you can see, this will be same. Okay, so this is same code whatever we have done. So this is 1 ms. 1-2 times you do submission and it will come to 1 ms. It's just because the servers are starting for Leetcode, so this is 1 ms now. So this is it, guys, for this video. I hope you understood this video. And one more suggestion for everyone who is watching this video right now: just don't need to watch the videos. First of all, try to code it out yourself. Once you are not able to do it, try out your brain at any and everything you can do. First try out with brute, then go on with efficient. If not, then come to this video, watch it again, and then code it out with me itself. So this is it, guys, for this video. I hope you enjoyed watching this video and learned something new today. And if this is the case, kindly give it a like and comment out your doubts. I will answer all of your queries as soon as possible. Thank you, guys. See ya in next video.